A huge underwater volcano has erupted near the deepest place on Earth. An underwater volcano has erupted near Challenger Deep, the deepest and most hostile place on Earth, unleashing chaos on a global scale. Tsunamis surged across coastlines, seismic waves rippled through the planet, and a new mystery has emerged from the ocean's abyss. What unimaginable forces could trigger such destruction? And what secrets lie hidden within the crushing depths of the Mariana Trench? This is no ordinary eruption. It's a once-in-a-lifetime phenomenon that could redefine how we see our planet. Let's dive into the extraordinary story of nature's raw power and its enigmatic legacy. Part 1. Geological Context and Challenger Deep. Beneath the vast expanse of the Pacific Ocean lies one of Earth's most enigmatic regions, the Mariana Trench. Stretching over 2,500 miles and plunging nearly 36,000 feet, this trench holds Challenger Deep, the deepest point on the planet. The pressure here is over 1,000 times greater than at sea level, an environment so extreme that it crushes anything unprotected. For decades, this alien-like world has captivated scientists with its hydrothermal vents, unique geological features, and bizarre ecosystems. Now it has become the epicenter of a colossal underwater eruption. Challenger Deep is situated at the boundary of two major tectonic plates, the Pacific Plate and the Philippine Sea Plate. This subduction zone, where one plate is forced beneath the other, is a geological hotspot. As the Pacific Plate descends into Earth's mantle, it melts and generates magma, fueling volcanic activity deep below the ocean floor. For millions of years, these forces have shaped the trench into a dynamic, ever-changing landscape of peaks, valleys, and volcanic vents. The recent eruption near Challenger Deep began with subtle seismic tremors, barely perceptible vibrations detected by sensors placed along the ocean floor. Initially, these movements were dismissed as routine tectonic activity. After all, this region is no stranger to earthquakes or small-scale volcanic disturbances. However, the tremors intensified, becoming deeper and more concentrated. Within hours, oceanographic stations detected rapid changes in water temperature and chemical composition, signaling magma on the move. This was no ordinary event. It was the precursor to a massive underwater explosion. At a depth of over 20,000 feet, the seafloor ruptured. Magma, superheated gases, and ash erupted with unimaginable force, sending shockwaves rippling across the Pacific. The sheer scale of the eruption stunned scientists as plumes of material rose miles into the water column. This seismic activity registered globally, drawing immediate attention from geological research teams and emergency management agencies. What makes this eruption so significant is not just its size, but its location. Submarine eruptions are notoriously difficult to study due to their remote and inaccessible nature. Yet this event near Challenger Deep offers a rare window into the processes shaping Earth's interior. By studying the seismic activity, chemical changes, and volcanic plume, scientists hope to unlock new insights into the mechanisms driving underwater volcanism. This eruption also highlights the immense power of our planet. The Mariana Trench, often viewed as a quiet abyss, has proven to be a hub of geological energy. The forces unleashed here remind us of the dynamic nature of Earth, a planet that is constantly shifting, evolving, and creating. Part 2. The eruption and immediate consequences. The recent underwater eruption near Challenger Deep began with subtle warnings that soon escalated into a geological event of unprecedented magnitude. Deep beneath the Pacific Ocean, sensors along the seabed detected unusual seismic activity. At first, these tremors were believed to be routine tectonic movements, a common occurrence in this volatile region where the Pacific Plate subducts beneath the Philippine Sea Plate. But within hours, the seismic waves intensified, becoming deeper, more concentrated, and far more energetic than expected. At a staggering depth of over 20,000 feet, the seafloor gave way to an explosion of magma, superheated gases, and ash. The pressure at this depth is so immense that the event was initially thought to be impossible to observe directly. However, as magma burst through the ocean floor, it triggered a cascade of changes in the surrounding environment. Plumes of volcanic material surged upward, forming massive underwater clouds of ash and debris. The explosion generated shock waves so powerful that they were detected on seismometers around the globe, alerting scientists and emergency response teams to the scale of the event. One of the most immediate and alarming consequences of this eruption was the generation of tsunamis. Although submarine eruptions rarely produce large waves directly, the violent displacement of water and material near steep underwater slopes heightened the risk. Coastal communities across the Pacific Rim went on high alert as tsunami advisories were issued. In some areas, minor waves reached shorelines, causing localized flooding and raising concerns about the potential for larger events. Emergency management agencies closely monitored the situation, knowing that any further seismic activity or undersea landslides could amplify the danger. In addition to the risk of tsunamis, the eruption caused significant changes to the local marine environment. The release of immense heat from the magma caused seawater to boil and vaporize near the eruption site, leading to rapid temperature increases in the surrounding waters. This phenomenon disrupted marine ecosystems, particularly those reliant on stable conditions near hydrothermal vents. The ash and debris from the eruption formed a thick underwater plume that spread across miles of the seafloor, burying habitats and altering the local topography. The environmental impact of this sudden upheaval is still being assessed, but scientists fear long-term consequences for deep-sea ecosystems. What makes this eruption so unique is not just its scale, but its location. Challenger Deep is one of the most inaccessible places on Earth, making real-time observation of this event a rare and invaluable opportunity for science. The intense pressure and extreme conditions at such depths present significant challenges for exploration and data collection. However, advances in technology, including remotely operated vehicles, ROVs, and autonomous underwater drones, have allowed researchers to study this event more closely than ever before. These tools are capturing high-resolution images and collecting samples from the eruption site, providing unprecedented insights into the processes driving such colossal underwater explosions. Another remarkable aspect of this eruption is its sheer power. The volume of magma released rivals that of some of the largest submarine eruptions in recorded history. As the lava spread across the seafloor, it began forming a massive volcanic edifice, altering the underwater landscape in real time. Advanced sonar mapping has revealed a rapidly growing structure, with lava flows extending outward to create a new volcanic ridge. If the eruption continues at its current rate, scientists predict that this structure could eventually breach the surface, forming a new volcanic island, a rare and awe-inspiring process that has occurred in places like Iceland and Hawaii. While the eruption's immediate consequences are profound, it has also raised critical questions about the broader implications for the planet. The release of gases, such as carbon dioxide and sulfur dioxide, into the ocean has altered the chemical composition of the water. These changes could have cascading effects on marine life, potentially disrupting food chains and impacting fisheries relied upon by millions of people. Moreover, the ash and debris from the eruption are spreading across the ocean floor, burying habitats and creating new challenges for species already adapted to extreme conditions. For some organisms, this upheaval may be an insurmountable challenge, while others may adapt and even thrive in the newly formed environments. The eruption near Challenger Deep is a stark reminder of the immense power of our planet. It highlights the dynamic processes that shape Earth's interior and surface, offering both opportunities for scientific discovery and sobering lessons about humanity's vulnerability to natural forces. This rare event, occurring at such an extreme depth, provides scientists with a unique chance to study underwater volcanism in action. The data collected from this eruption will undoubtedly deepen our understanding of the processes that govern Earth's most mysterious regions. As the ash settles and the immediate danger subsides, the world watches with awe and curiosity. This eruption is not just a geological event. It is a window into the raw, unrelenting power of our planet, and a testament to the resilience of life in even the harshest conditions. It challenges humanity to continue exploring, understanding, and coexisting with the forces that shape the world we call home. Part 3. Ecological impacts and the formation of a new island. The underwater eruption near Challenger Deep has not only reshaped the seafloor, but has also caused profound ecological disruptions and transformations. This event, occurring in one of the most unique and extreme environments on Earth, highlights the delicate balance between destruction and renewal in nature. While the immediate aftermath has brought challenges for existing ecosystems, it has also set the stage for new life to emerge. The eruption's impact on the surrounding marine ecosystem is both dramatic and far-reaching. One of the most affected areas includes hydrothermal vent communities, clusters of life that thrive in the extreme conditions near the Mariana Trench. These vents, which release chemical-rich fluids from Earth's interior, support a variety of organisms, from giant tube worms to specialized bacteria. The eruption has buried many of these vents under layers of ash and volcanic debris, displacing or destroying entire communities of organisms adapted to these harsh conditions. The loss of these ecosystems is significant, as they represent some of the most unique biological environments on the planet. However, nature often finds a way to adapt. As the eruption subsides and the magma cools, the newly formed volcanic rock will provide a fresh substrate for marine organisms to colonize. Over time, these rocks can become home to corals, sponges, and other species, giving rise to entirely new ecosystems. This process, though slow, demonstrates the resilience of life and the cyclical nature of destruction and renewal. Similar events in the past have shown how ecosystems can adapt and flourish in the aftermath of volcanic activity, creating biodiversity hotspots where none existed before. Beyond its ecological impact, the eruption has initiated the formation of a new volcanic island. As magma and ash settle on the seafloor, they are accumulating to create what scientists call a proto-island. Early sonar imaging has revealed a structure rapidly growing in size, with lava flows spreading outward and stacking atop one another. While the island remains submerged for now, continued eruptions and material deposition could eventually push it above the ocean's surface. If this occurs, it would mark the birth of a new landmass, an extraordinary event that has shaped some of the most iconic islands in the world. The Pacific Ocean is no stranger to such geological phenomena. For instance, the Hawaiian Islands were formed by millions of years of volcanic activity, as magma from a hot spot beneath Earth's crust continuously emerged to create new land. Similarly, the island of Surtsey off the coast of Iceland emerged from an underwater eruption in 1963, providing scientists with a unique opportunity to study the birth of an island and its ecological development. The formation of a new island near Challenger Deep could offer similar opportunities, allowing researchers to observe how landforms evolve and how life colonizes newly exposed surfaces. The ecological implications of this new island are profound. If it rises above the waterline, it could become a nesting ground for seabirds, a refuge for marine mammals, or even a starting point for vegetation to take root. The interactions between terrestrial and marine ecosystems in such a setting would provide valuable insights into the processes of ecological succession and the interconnectedness of life on Earth. Additionally, the unique chemical composition of the volcanic material could influence the types of organisms that thrive on the island, creating a distinct and potentially unprecedented ecosystem. While the formation of a new island is an inspiring example of nature's creativity, the eruption's broader ecological consequences cannot be overlooked. The ash and debris from the eruption have spread across miles of seafloor, disrupting food chains and altering habitats far beyond the immediate area. Species that depend on stable conditions near the trench may struggle to survive, while opportunistic organisms could exploit the changing environment to their advantage. This dynamic interplay between loss and renewal underscores the complexity of life in the deep ocean. Another concern is the potential long-term effects on marine biodiversity. The release of gases such as carbon dioxide and sulfur dioxide during the eruption has altered the chemical composition of the water, affecting the pH balance and potentially leading to acidification. Such changes can harm shell-forming organisms, coral reefs, and other species critical to the marine food web. While the deep ocean is often thought of as a stable environment, events like this demonstrate its vulnerability to sudden and large-scale disturbances. Despite these challenges, the eruption offers an unparalleled opportunity for scientific study. Researchers are already using advanced technologies such as remotely operated vehicles, ROVs, and underwater drones to collect data and monitor the evolving landscape. These tools provide high-resolution images of the seafloor and allow scientists to study the chemical and physical changes in real time. The data gathered will deepen our understanding of how underwater eruptions influence both geology and biology, offering lessons that could be applied to similar events in the future. In the grander scheme, the eruption near Challenger Deep is a testament to the power and resilience of our planet. It serves as a reminder that even in the face of destruction, life has the capacity to adapt and flourish. Whether through the creation of new ecosystems on volcanic rock or the emergence of a new island from the ocean's depths, this event encapsulates the dynamic and ever-changing nature of Earth. As scientists continue to study its impact, we are reminded of the interconnectedness of life and the importance of understanding the forces that shape our world. Part 4. Global Risks and Environmental Changes. The underwater eruption near Challenger Deep has unleashed a series of environmental and global risks, emphasizing the intricate connections between Earth's systems. From chemical disruptions in the ocean to threats of tsunamis and broader climate impacts, this event reveals the far-reaching consequences of natural disasters. One immediate concern is the alteration of ocean chemistry near the eruption site. The release of carbon dioxide, CO2, and sulfur dioxide, SO2, into the water has accelerated acidification, posing a severe threat to marine organisms. Corals, mollusks, and plankton, which rely on calcium carbonate to form their shells, are particularly vulnerable. As these foundational species decline, marine food webs may destabilize, disrupting fisheries that millions depend on for their livelihoods. Furthermore, the ash and debris from the eruption have clouded the water, reducing sunlight penetration and temporarily hindering photosynthetic organisms vital for oxygen production. Another critical risk involves potential tsunamis triggered by undersea landslides. While submarine eruptions themselves rarely generate large waves, the steep and unstable slopes surrounding Challenger Deep are susceptible to sudden collapses. A significant landslide could displace massive amounts of water, creating tsunamis capable of traveling vast distances across the Pacific. Coastal nations such as Japan, the Philippines, and the United States remain on high alert, with monitoring systems actively tracking any signs of unusual activity. Although proactive measures like evacuation drills and emergency plans are in place, the unpredictable nature of undersea landslides keeps the risk ever present. The eruption's impact extends beyond the immediate region, potentially influencing global climate systems. Volcanic eruptions release CO2, contributing to the global carbon cycle and potentially exacerbating climate change. At the same time, SO2 can form sulfate aerosols when it interacts with seawater, reflecting sunlight and temporarily cooling the Earth's surface. This dual impact, warming through CO2 and localized cooling through aerosols, highlights the complex ways volcanic activity interacts with atmospheric processes. Additionally, the redistribution of heat and nutrients caused by the eruption may disrupt ocean currents, which play a crucial role in regulating global temperatures, supporting biodiversity, and driving weather systems. Even minor disruptions in these currents can have cascading effects, altering rainfall patterns, intensifying storms, and impacting agriculture. The marine food chain faces further challenges from the eruption. Volcanic ash and debris have buried large portions of the seafloor, destroying habitats and limiting food availability for benthic organisms. Simultaneously, the influx of nutrients from the eruption has fueled algal blooms in the upper water layers. While these blooms can temporarily increase productivity, they often lead to oxygen depletion in deeper waters, creating hypoxic dead zones where marine life struggles to survive. Such conditions threaten biodiversity and have direct implications for commercial fisheries. The eruption also underscores humanity's vulnerability to natural disasters. Despite technological advances and scientific understanding, events like this reveal the limits of our ability to predict and mitigate large-scale environmental changes. Coastal regions around the Pacific Rim, with dense populations and vital infrastructure, are particularly at risk from tsunamis and other ripple effects. Strengthening early warning systems and improving infrastructure resilience are critical steps to mitigate these risks and protect vulnerable communities. Amid the challenges, this eruption offers an opportunity for scientific collaboration and innovation. Advanced technologies, such as autonomous underwater vehicles and satellite imaging, are providing valuable data on the dynamics of submarine eruptions. These tools allow researchers to monitor changes in real time, improving our understanding of volcanic processes and their broader implications. Policymakers and international organizations must also prioritize global cooperation to address the long-term impacts of such events and develop strategies for future preparedness. The Challenger Deep eruption is a stark reminder of the dynamic nature of Earth's systems and the delicate balance that sustains life on our planet. It emphasizes the importance of understanding and respecting these forces, as disruptions can have profound and far-reaching consequences. While the immediate focus is on mitigating risks, the event serves as a call to action to deepen our understanding of Earth's processes and strengthen our ability to adapt to future challenges. As research continues, the Challenger Deep eruption stands as both a scientific milestone and a reminder of humanity's shared responsibility to protect and preserve the planet. It is a testament to the resilience of Earth's systems and the urgency of fostering a sustainable relationship with the forces that shape our world. Part 5. Research opportunities and scientific potential. The underwater eruption near Challenger Deep has provided scientists with a unique opportunity to study Earth's inner workings in one of its most extreme environments. Using advanced tools such as remotely operated vehicles, ROVs, and autonomous underwater drones, researchers are capturing high-resolution images and collecting samples of magma and volcanic rock from the seafloor. These samples offer valuable insights into the composition of Earth's mantle, where the magma originates, and the processes driving tectonic activity in subduction zones. Understanding these dynamics is critical for advancing our knowledge of plate tectonics and volcanic formation. One particularly intriguing discovery from the eruption is the presence of rare earth elements in the volcanic material. These minerals, vital for modern technologies like smartphones, electric vehicles, and renewable energy systems, have sparked interest from both scientists and the mining industry. While the potential to extract these resources could address growing global demand, it also raises ethical and environmental concerns. The ecosystems surrounding Challenger Deep are fragile and already under stress from the eruption. Deep-sea mining operations risk causing long-term ecological damage, disrupting habitats, and polluting the surrounding environment. Balancing the need for resources with the imperative to protect marine ecosystems is a critical challenge for policymakers and researchers alike. The eruption also underscores the importance of international collaboration in oceanographic research. Nations with advanced technological capabilities have mobilized to study this event, deploying cutting-edge equipment and sharing data to analyze its impacts comprehensively. This collaborative approach demonstrates the global significance of studying underwater volcanic activity and the need for unified efforts to address its challenges. Beyond its immediate scientific opportunities, the eruption highlights how little we still know about the deep ocean. Despite covering the majority of Earth's surface, much of the seafloor remains unexplored. Events like this remind us of the potential for new discoveries that could revolutionize our understanding of geology, biology, and resource management. The data collected from this eruption will not only expand our knowledge of submarine volcanism, but also provide critical insights for managing Earth's natural resources responsibly. As scientists continue their work, the Challenger Deep eruption stands as a powerful example of the dynamic nature of our planet. It offers a rare chance to witness geological processes in real time while challenging us to balance exploration with conservation. This event reminds humanity of the profound mysteries that lie beneath the ocean's surface and the responsibilities we bear in uncovering them. Part 6: Human Significance and Our Connection to Nature. The underwater eruption near Challenger Deep serves as a stark reminder of the immense power of nature and humanity's limited ability to control or mitigate such overwhelming forces. Despite our technological advancements and deepening scientific understanding, events like this highlight our vulnerability and the interconnectedness of Earth's dynamic systems. It is a humbling moment that compels us to reflect on our place within the intricate web of life that sustains our planet. This eruption underscores the urgent need for international collaboration in addressing the challenges posed by natural disasters. The interconnected nature of Earth's systems ensures that the effects of such events rarely remain confined to a single location. From tsunamis threatening distant shores to disruptions in global ocean currents and atmospheric patterns, the impacts ripple far beyond the Mariana Trench. Addressing these challenges requires nations to come together, pooling resources and sharing knowledge to study and respond to these phenomena. Collaborative efforts, such as deploying advanced monitoring technologies and conducting comprehensive data analysis, are essential for improving our ability to predict and prepare for such events. The eruption also emphasizes the delicate balance between exploration and conservation. It has reignited interest in the uncharted depths of the ocean, where much of Earth's history and mysteries remain hidden. Challenger Deep is a frontier that has been visited by only a handful of people, yet it holds critical insights into the processes that shape our planet. Events like this highlight the importance of investing in oceanographic research, not only to satisfy human curiosity, but also to deepen our understanding of the systems that sustain life on Earth. However, as we push the boundaries of exploration, we must also prioritize conservation, ensuring that our pursuit of knowledge does not come at the expense of the delicate ecosystems we aim to understand. Beyond the scientific implications, this eruption offers a unique opportunity to inspire humanity. It reminds us of the resilience of life and the incredible capacity of Earth to adapt and renew itself. While ecosystems near Challenger Deep have been disrupted by the eruption, new habitats are already forming on the cooled volcanic rock, demonstrating nature's cycle of destruction and rebirth. This resilience is a powerful metaphor for humanity's own capacity to adapt and thrive, even in the face of challenges. The event also serves as a call to action, urging humanity to embrace a more sustainable relationship with the planet. It highlights the importance of reducing our environmental impact, investing in renewable energy, and protecting marine biodiversity. The lessons learned from studying this eruption can guide us in making better choices for the future, ensuring that we leave a thriving planet for generations to come. Ultimately, the Challenger Deep eruption is more than just a geological phenomenon. It is a moment of profound significance. It invites us to explore, reflect, and act with a renewed sense of responsibility toward the natural world. By fostering global cooperation, prioritizing environmental stewardship, and embracing the spirit of discovery, humanity can rise to meet the challenges of living on a planet as dynamic and interconnected as ours. The eruption near Challenger Deep is more than a geological event. It's a powerful reminder of Earth's strength and wonder. It urges us to explore responsibly and protect the planet we call home. Join us in uncovering more of Earth's mysteries. Don't forget to like, share, and subscribe to stay updated on incredible stories like this. Thank you for watching, and let's continue this journey of discovery together.